All right. So what we're going to talk about in this video is the relationship between moles and mass. Like, moles are a great thing and particles are great, but the reality is that if we're going to go measure out a substance, we need to have it in either a mass or a volume, because it's about the only things that we can measure quantities of in a lab. Okay, so some background stuff that we already know. The last time we talked about mass and elements, we used atomic mass units, which we defined as about the mass of one proton or one neutron. It's not quite there, and we talked about what it really is, but for right now, okay, this is a functional, useful definition. Which means that hydrogen with just one proton and no neutrons has a mass of about 1. Okay, and then we talked about how the isotopes exist. Some hydrogen atoms have a neutron in them, so we averaged this number out because a few are going to actually have a mass of 2, and then we averaged this to get a number right here. So we could measure the mass of a given element in atomic mass units. Okay, and that's what these numbers that are given on the table are. They're average atomic masses in atomic mass units. It tells me about how many protons and neutrons are going to be in a given element. Okay, well, that's not really useful. Now, how big exactly is an atomic mass unit? I need to be able to talk about this in grams. How many grams does an atomic mass unit weigh? Well, you're never going to believe this, but conveniently, one atomic mass unit is about 1 over 6.02 times 10 to the 23rd grams. I told you earlier in a couple videos ago that the 6.02 times 10 to the 23rd has a reason. This is it. It turns out that it takes 6.02 times 10 to the 23rd protons to make a gram. So why is this important? Why is this useful? Well, one atom of hydrogen is going to have a mass of about 1.00794 atomic mass units. But 6.02 times 10 to the 23rd atoms of hydrogen is going to have a mass of 1.00794 grams, right? If I've got 6.02 times 10 to the 23rd of them, then I've got grams. Well, we know that atoms, okay, 6.02 times 10 to the 23rd atoms is 1 mole. So I can say 1 mole of hydrogen has a mass of 1.00794 grams, and I never have to talk about how many atoms I have. Okay, I know that things are going to react in ratios of moles anyway, so I don't have to constantly go to and from the number of atoms as long as I understand that we're talking about a mole. Okay, so we're going to look here at what we call a molar mass, okay, which has the best definition ever. And kids are like, oh, I can't remember the definition for molar mass. It's really, really very, very, very simple. It is the mass of 1 mole of a substance. Now, oops, I ran out of room. Okay. Different textbooks will use the words gram formula mass, they'll use the term gram formula mass, gram molecular mass, and gram atomic mass. It's dumb. They all mean molar mass. They're giving a different distinction to ionic compounds and covalent compounds and monatomic elements, but we just don't care. All of them, molar mass. Okay, so if I want the molar mass of something very, very simple, like iron, which is a monatomic element, right? All I have to do is come over here and find the number straight off the table, right? 1 atom of iron would have a mass of 55.4845 atomic mass units, but I don't care about atomic mass units. 1 mole has a mass of 55.845 grams. Okay, so the molar mass of iron is 55.845 grams. That's all there is to it. Okay, Well, what if I wanted the molar mass of something a little bit more complicated? Let's say I want the molar mass of sodium chloride. Well, that has two substances in it. So what I do is I find the mass of sodium, which is this 22.98. Now we're going to write that to 98. Okay, and chlorine over here, which has a mass of 35.4527. Okay, and we add them together. 22, right, 0.98, 35.4527. Okay, and we add them together. Like that. And we put units on them. Humor me here. Right? Grams. Sodium, grams of chlorine will equal so many grams of sodium chloride. Okay? One more example. What if I need the molar mass of water? Well, I can look those numbers up, and I'm going to get hydrogen is 1.00794 grams. Hydrogen, and you'll find oxygen is 15.9994 grams of oxygen. But I've got that 2 right. Sorry. Okay. But I have that 2 right there also, right? Which means I need to take this number and multiply it by 2 before I put them together, which means I'm going to need a calculator. And once again, I forgot to bring it over. Now I can even find one. Okay, so I'm just going to assume that you guys can add numbers together on your own, and I'm not going to work through this one. It's going to be about 18.01 something. Okay, because I've done this before. Grams H2. You can do the math yourself, right? Remember, multiply, then add, but that's all there is to this. Okay, now we're going to use this in the next lesson to then find what if I had so many moles of water, or if I have these in reactions, what happens. But for right now, this is all you need to be able to do, okay, is to add up the atomic masses, okay, that come off of here. Once again, all you have to do is pull the number straight off the table and slap a grams onto the end of it instead of an AMU. Okay, super simple. Good luck.